Villegas.
Hi, my name is Lourdes Garza.
My name is Valina Lizondo.
My name is Melissa Gonzalez, and today we're going to show you some basic concepts about right triangles and how to solve them in real life. A right triangle, it's a triangular shape with one right angle and two acute angles.
Okay, so this is the basic form of the Pythagorean theorem. The sides of the triangle here are based on the Pythagorean theorem. Side A is here, side B is here, and side C is also called the hypotenuse, which is this side.
Today I'm going to show you the 6 trigonometric functions. First, there are 3 main ones. It's sin, cos, and tan. The other 3 are its reciprocals. For sin, it's going to be CSC. For cos, it's going to be CEC. And for tan, it's going to be COT. To find these signs, you can use a method that it's called SOHCAHTOA, which means that sin is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. This is SOHCAHTOA.
For this problem, we need to identify the angle of elevation of the sun if a tree that is 6 meters long casts a shadow of 5 meters. In here, we will do this line so we can make the right triangle. This angle of elevation, we're going to call it theta. For this specific problem, we don't need to find the distance of the hypotenuse since we can use the formula of tangent. Tangent of theta would be opposite over adjacent. This would be the opposite angle, opposite side, and here will be the adjacent side. So we will plot these numbers on the formula, 6 over 5. And remember that to solve this problem on the calculator, you need to press the tan -1 button divided by 6 divided by 5, and the answer will be 50.19 degrees of the angle of elevation.
If we have a specific point 135 meters away from a structure that is 215 meters high, we have to find the angle of elevation. But for that, first we have to find the hypotenuse. We will find that through the Pythagorean theorem. So we have to plug in the values that they are. A squared plus B squared equals C squared. So A squared is going to be 135 meters. B squared is going to be 215. And we have to find our C squared. For that, we have to isolate the C, which gives us the square root of 135 squared plus 215 squared. If we put it in the calculator, we get a value of 253.9 meters. So now we have to find our angle of elevation. For that, we have to use the sine, which is opposite over hypotenuse. So our opposite side is going to be 215 our hypotenuse 253. And we have to do it's inverse so that we can find the actual value of theta. So sin -1, then we get a value of 57.9 degrees.
For this real life problem, we're going to use a person that measures 154 meters, standing below the sun and casts a shadow that measures 1.15 meters. So we need to get the angle of elevation from the sun. We're going to call it theta. So for this, we're going to use this side and this side, which is the opposite and the adjacent, and use the trigonometric ratio of tan, which is opposite over adjacent. And we're just going to put the numbers of the sides, which is 1.54 over 1.15. And for this, we're going to use the inverse function of tan, 1.54, 1.15. So we're going to plug in the calculator this function. So it's inverse tan of 1.54 over 1.15. And it's going to give us the answer of theta. Which is 53.25 degrees.